Hello. In this video, I'm going to explain problem 2 from the 2013 F equals MA contest. In this problem, we have Jordy and Diego, and I'm going to label them J and D. We see that Diego is here, 10 meters from the wall, and Jordy is here, 20 meters from the wall. And we see that Jordy throws a ball at an angle of 30 degrees above the horizontal, and it collides elastically with the wall, and Diego catches it. And we're asked, how fast does Jordy need to throw the ball so that Diego will catch it? So, let us draw a diagram with a little bit more space. Now, the trick is that because of the elastic collision, what does that mean in this context when you have a ball colliding off a wall? So it'll be like this, like that. Well, what it means is that if you draw it's not a very good tangent line, if you draw the tangent line at both points, then the angle of incidence will equal the angle of reflection. Where you draw the perpendicular line to the wall and then draw the angles of the tangent line to the trajectory on both sides of the collision. And so this motivates a particular trick. Here we have Jordy, and here we have Diego, and here we have the wall. But since the ball gets reflected, what we can do is that we can just reflect this entire trajectory onto the other side of the wall. And so let's call this new point D prime. And now we see that the ball needs to travel a total of 30 meters horizontally, which is the sum of those two distances. So now this becomes a pretty standard projectile problem where we have a projectile launching from level height with a speed v and an angle theta. We're given that this angle, so this is not the same angle as in this diagram, but it's theta equals 30 degrees. And now we need to know what speed and we have a known distance, and we need to calculate the speed. So once again, this is a pretty standard problem, but I'll still show it here. How do we compute this total range? So I'll call this R. So R, the total range, will be the total time of flight multiplied by the horizontal speed, which will be v cosine theta. Now the time of flight is just 2 times the amount of time it takes for the ball to reach 0 vertical velocity. Now the vertical velocity initially is v sine theta, and the downward acceleration is g, so the time it takes to reach 0 vertical velocity is v sine theta over g. And so you multiply that by 2, and so you get the time of flight. And so now you have R equals 2 v squared sine theta cosine theta over g, or v squared sine of 2 theta over g. This is a pretty standard calculation, and so I would not be surprised if, once you do this calculation enough times, you end up just memorizing the result. But it's fairly easy to calculate if you do not know this result. So now we need to calculate v, and so we can just rearrange. We'll get the square root of gr over sine of 2 theta. And so we can use our standard conventions. So g is 10. We know that r, the range, is 30 meters. And so we get the square root. So this is all in SI units. 300, sine of 2 theta will be sine of 60 degrees, which is root 3 over 2. So we will end up getting the square root of 30 times 10 divided by root 3 over 2. Again, this is all in meters per second because I've worked in all SI units. And so we had V equals, this is over 2. So ultimately what we get is 100 root 3. So we get square root of 200 root 3 meters per second. And at this point, you can write that as 10 times the fourth root of 12 meters per second. And now we can just do this with a calculator. So 12 to the power 1/4 is roughly 1.861. Multiply that by 10 is roughly 18.6 meters per second. Now let's go back to the start. We see that that is closest to 19 meters per second. And that's our answer. All right, so I hope that was helpful, and thank you for watching.